Thank you, Kobe. I did a workshop the last 2 days, and my voice is starting to go. So I apologize for that. Let's see. My presentation is writing games in Ruby. If we have time, we can go a little bit slower. You guys, if you want to follow along, you can gem install Gosu, which is the library that all these examples that we're going to go through are built upon. And you can even go to GitHub, my repo here in GitHub, if you want to follow along with the examples. So, all right, I have a confession. My confession is that writing games is fun. You may not have known that, right? Which is awesome. But it's even more fun because, why? Why is it so much fun? Because Ruby. Ruby is super fun. Writing games is fun. You put it together, and it's fun squared. So this is my little Ruby guy. This is one of my claims to fame. But I love this because this is how I feel about Ruby, right? Adventurous and awesome and ready to tackle. So I would like to see more fun at, I'd like to see us have more fun with Ruby. And games are a great way to do it. So let's talk about Gosu. Gosu's a fantastic game library. I guess, show of hands, who is familiar with game programming? Oh, cool. So maybe like a fifth of the room. Who's familiar with Gosu or has heard of Gosu before? Pretty much the same audience. Okay, this is great. So this is new stuff, and that's exciting because you'll get to learn new things at conferences. So if you've got internet, which you should, because it's great up here, it's horrible downstairs, gem install Gosu, and it will try to compile, and we'll move on. Okay. You can also go to libgosu.org and look at the documentation, and we'll step through some of this documentation in this presentation. All right, so what can you do with Gosu? Gosu's, I guess we should talk about what Gosu is. And we're going to talk a little bit about what you can do with it. So here's the website, libgosu.org. It has a bunch of information. Gosu is a C++ library. And so it's a low-level game library written in C++, but it has first-class Ruby bindings, which means that all of the concepts that if you wanted to use Gosu with C++ map directly to Ruby. So it just means that it's a really fantastic Ruby library as well as a C++ library. Okay, let's take a look at what we can do in Gosu. So I'm going to check out my Gosu library. Can you guys see this? Yeah. I'm wondering what my resolution is here. How's that? All right. So if you check out the Gosu Git repo, you can change into the examples directory. This is just Gosu. So if you go to libgosu here, what is my resolution? My resolution is crazy big. So if you go here, you'll get to the GitHub repo for Gosu. So this is just, if you check out the Gosu repo on GitHub, there will be an examples directory. I need to switch to my Gosu gem set. And once you have Gosu installed as a gem, you can go to the repo, and there's a file called Captain Ruby, which is pretty fun. I'm I'm going to change my displays here, get it a little bit bigger. There we go. All right. So this is a little game that comes with Gosu. Shows you how to play Gosu. And it's just a little platformer game. And it's super hard. All right. This one does not have sound. I'll show you some other ones that do.
Tell me when you do, and I'll plug you in. Otherwise, you create a vibration on that.
Okay. I'll try not to talk when we have sound then. Ah! It's horrible. I can never get to that upper right-hand corner because you got to go all the way back down. Yeah, that's a pain. Oh, yeah, good luck getting all the rubies. All right. All right, so that's possible. The code to all of this is available in the Gosu library. So it is 224 lines long for the entire thing, which is not too bad. That includes all the code to build the map and all of the input to move around. So in less than 250 lines of code, you've got that game. The what? What about the graphics? Yep, that's all Ruby code, right? All that logic to play that game is all Ruby code. So here's another example. So I've got some little kids, they were littler a couple years ago, and I had an old netbook, like the really small 9-inch, and they always wanted to sit in my lap and be like Dad and work on the computer, and I needed to move them off and focus them on something else. And I had this little computer that looked just the right size for them, so I created this little app called Little Brat, because usually I was frustrated when they got in front of me, and so I just type Little Brat, and here, we're gonna have some sound here, Kobe. So, there you go. So they would play that for hours, and it was awesome. Another one that I wrote, so I didn't write the Captain Ruby, but I did write this. I wrote this in 2010. I gave an earlier version of this talk in 2010, and I created another gem that uses Gosu. This is all written in Ruby, called Escape. Begin. Conf. And so this is very 2010, big into ninjas, right? And the whole point fail. Begin. Is to try and get to the exit.
You win.
And
begin.
Keep doing it, and keep adding more snakes.
You win.
Begin. And, oh man.
You win.
All right. So that was me as well. There is a gaming contest where you get a weekend, 48 hours, called Ludlum Dare, to build a game completely on your own as a single person. And they want to see how far you can get in 48 hours to build your own game. All the art assets, all the code needs to be done in the 24 hours. And this library is a fantastic little library to compete in the Ludlum Dare contest. All right. So lots are possible. We saw lots of different types of games. We saw Captain Ruby, which was more of a classical platformer. We had My Little Brat, which is a key smasher for little kids. And that Escape to RubyConf, which is more of an arcade kind of style game. So there's lots of things that we can do with Ruby with gaming. And so, show of hands, who would like to write games in Ruby? All right, good. Almost half everybody. Good. So we're going to talk about that. Here's the thing. It's super easy to do. It's not complex, right? And it's actually really fun as well. So here's how we're going to do it. Here's the first thing. There's only a handful of concepts we need to understand in order to write games. The first is we need to understand this thing called the game loop, right? And so if you've done any kind of Windows or UI programming, you're familiar with kind of the evented model where your application will raise events, so you'll have to respond to it. That's the exact same thing we have within a game loop. Your game is going to have a game loop. That loop is going to just loop over and over and over and over again. The game loop is run by Gosu, by the Gosu window object. And what it's going to do is it's going to run over and over, and 60 times a second, it's going to call the update method, and then it's going to call the draw method. And then every time you press or depress a button, it'll call the button down and the button up method, right? And that's basically it. That's all there is to it. If you kick over here, on libgosu, we'll see here is the there we go. Here's the RDoc documentation for Gosu, for window. And down here in these callbacks, we'll see that there's an update method, and there's a draw method, a button up method, and a button down method, right? And so that's all it is. You're going to create a new instance of this Gosu window, and then we're going to define what we want to do within those methods. That's basically it. Okay, so let's do that. Let's begin, as it were. Okay. Let's just start. So what I'm going to do is I'm going to open up my editor, and I'm going to create this directory called Hello World. And in this Hello World is a very, very simple Ruby file. I'm going to create a new class called Hello World Game that is going to inherit from Gosu window. My initializer is going to take 3 parameters, which is going to be a width, a height, and whether or not this game is going to be running in full screen. I call super because Gosu is intending to have that initialized called. If I didn't want to pass that in, I could just put like 1024 by 768 here, and then false or true in super, and then I wouldn't have to have it defined in my initializer. But I like to have those default values in my initializer. Okay, and we're going to do Hello World app, so we're going to print out Hello World in the caption, and that's all it is. We've got our methods defined for update and draw, so we can put stuff in there. That makes sense? Everybody's following? So to call it is pretty easy. Well, we're going to cd to the Hello World directory, and we're just going to call Ruby hello world.rb. And there it is, Hello World. And it doesn't do anything, but it's an 800 by 600 window. And that caption at the top says Hello World. Okay. If I hit escape or space, it's not going to do anything because we haven't told it to do anything. So let's tell it to do something. The first thing I'm going to do is I'm going to define that button down method, and it's going to get passed an ID. And I'm going to call close if that ID is the same as Gosu keyboard escape, right? And this is the first thing I do in pretty much every Gosu game is I just find a way to escape it because I don't want to have to try and click that little red dot. All right, rerun it. I hit escape and it closes. So we see that it's working. We got these callbacks happening. Now, there's more that we could do. I'd like to actually see a bigger hello world, not in the title bar of the window, but actually see something real. Now, there's a couple of ways I could do that. One, I could create an image that says hello world and just put that into that screen. Or we can use Gosu to do that for us. And so that's what I'm going to do here. In my initializer, I'm going to create a new object called image. And I'm going to ask Gosu to create this image for me because I don't want to go to Photoshop and build an image. So we'll ask Gosu image to create a new image from text. Okay? So let's kick over to the documentation. We looked here. This is the window documentation. Here's image. We know that this image object is going to have a height and a width. But there's also these class methods, from text, load tiles, and then the initialize, when we call new. Okay? So it's this from text that we want to call. From text takes 5 arguments. It takes the window that this text is going to be printed to. We're going to pass the text that's going to be created for that image, the font name, the font height, and then line spacing, width, and the alignment. We can start. There are default values for those, so we can drop those. So here I'm going to say from text. The first is self, because that's the window. We're passing our self into this. Next thing I'm going to do is I'm going to say hello, LA Ruby Conf. Okay. The third is the font name, and I need to specify a font name. If you have a font file, you can actually specify that, either that path or specify the path, and then it'll build that image with that font. I don't want to remember where that is or look it up because it's going to be different across platform. So one of the things I'm going to do is, where are you? Here we go. Default font name. Gosu will give me a default font name. And then let's make that 100 pixels tall. Okay? And then on draw, in order to actually put that on the screen, I'm just going to say we want image to draw at 0, 0, 0. And we'll talk about what those mean later. Okay, let's see if we can get that to work. And there it is. Hello, LA Ruby Conf. All right. What's that? It's the best game ever. What's great is that you press escape and it goes away. Escape. All right. Let's change it just to LA and do it again. All right, there we go. All right. The next thing is I want to make this centered, right? So let's take a look at the draw method. The draw method takes a bunch of arguments. Really, the first 3 are the ones that we care about, and the rest have default values, so we can leave them off if we're not going to change it. The first is X, the next is Y, and the third is Z. So let's see what those mean. All right. Here's our screen. We have an 800 by 600 screen. The X and the Y are the coordinates on the screen where we want something placed, right? So the upper left-hand corner is 0x and 0y. The bottom right-hand corner is 800x and 600y. The middle is going to be 400x and 300y. Make sense? Okay. So let's move over back to our code. So we know this is 800 by 600, so we can probably say 400 by 300 and get it in the middle. Let's run that. But it doesn't get it in the middle because that middle point is also the upper left-hand corner of our image, right? Is that? Okay. All right, so let's try and fix it. Let's see, what we could do is probably say maybe 400. This is the same thing as like self.width, actually. So we can say self.width minus image.width, because I don't know how big that image is, right? So self.height minus image.height. Oh man, I am live coding in front of a lot of people. I just realized that. Okay. Oh, that didn't work either. No, that didn't work. Oh, I know. No? Yeah, we need to divide it in half. So We'll divide that in half. Try it again. Ah, it doesn't work again. Why doesn't it work again? Oh, no. All right. Okay, so we're getting, we are getting advice on how to get it centered, right? So what we want is we want the center point of the screen, which is self.width divided by 2. So if we're 800 wide, we want that 400 value. And the vertical position, we want the total height, which is 600 divided by 2. But because we want the image centered, now we have to move those values up by half the height of the image and half the width of the image, right? And so let's see. So we'll see if this works. And it does! Yay! All right. So here's the thing about this. It's math, right? Writing games in Ruby is fun, but there's math involved, and sometimes you'll get that math wrong. Math, right? Solve that for the Wi-Fi password, right? Math. You thought you were done with after school, but you're not. Math is coming back. Okay, so there is math involved. That can be frustrating, but we're going to try and work through it. So one of the things that I would really like to do is I would like this image to do something kind of interesting, right? Because it's just sitting there, not really doing anything. It's not earning its keep. So let's make it earn its keep. All these things right here, this calculation, I don't know, I really don't want that in my draw. I don't want to add logic to my draw. I just want it to be responsible for drawing. So what I'm going to do is I'm going to come up here and I'm going to make an X instance variable, and I'm going to put that logic in X. Okay, and then I'm going to come over here, and I'm going to put that in Y. There you go. This podium is the worst for trying to type. Thank you. Okay. Now, this shouldn't change it. It doesn't. Same thing. So we're good to go. We've got these X and Y values. Now we can change them. So one of the ways that we can change them is to make them time dependent. So one of the things I like to do is I'm going to add a value. So I'm going to say math.sign match of time.now.2f, which is going to give me a float, right? And I'm going to multiply that times about 150. Okay? If I do that, and now it's going to go back and forth, right? So time is always going to be updating. Every time we call update, we're going to get a slightly different time. And so we're going to move that position slightly, every fraction of a second, 60 times a second. We're going to move that image. Let's do it again. Let's add math cosine of time.now.2f. And let's multiply that times 200. So it'll be just a little more exaggerated. And there you go. So math sine and cosine gives us a circle. We didn't do anything with that. This is all more math. Math is fun. Okay? Math and cosine are so blasé. Let's change this out to like a tangent. Right? Lower that so it doesn't actually shows up on the screen. Boom. All right. Okay, there we go. So we haven't really done much in this game, if you can call it a game. We built an image off of some text. We are taking input, so we know that when we press the escape button, we're going to close. And we are calculating position that we want this image to be. Now, there is math involved. We're saying however wide the window is, we're going to try and find the center mark. We're going to offset that by the size of the image. And then we're going to offset that by some value sine and cosine of the current time. Cool? All right. There's more we could do. Why don't we try to not only see the image, but see if we can hear stuff as well. Gosu has more that it offers us. Not just we don't just have the ability to print things to the screen. We can actually play songs, play sounds as well. So there are two different classes. One is song, which is intended to be a sound that's going to be playing for a long time. The other is a sample, which is intended to be a sound that you might have that might be happening multiple times. Multiple instances of a sample could be playing at the same time, but they're typically smaller. So just performance-wise, there's different characteristics for dealing with those resources within a game. And so there are the two. Let's look at what that documentation looks like, again, on the libgosu.org site. The methods, once we create it, we give it a window and a file name. We have a play and a stop for the song. And then the sample is pretty much the same. We have an initialize and then also a play. When we play it, we can give it a volume and a speed and whether or not we want it to loop. Okay. So let's open this up. On my desktop, I've got a couple of songs I'm just going to drop into this project. So let's see. Let's do Bubble. That's a good one. And here we go. Any Kim Possible fans in the audience? We'll do Communicator. All right. So back in our initializer, I'm going to create a song object, and that's going to be coming from Gosu. Song.new. Again, passing in self. Gosu window is a special object. You really should only ever initialize one instance of window, and that's because it's going to do a bunch of low-level system resource stuff in order to print to the screen. So that's why we're passing this window around so much. So we'll call self, and then it's going to be bubbles.mp3. Is that right? Yep, bubble.mp3. This is a Why the Lucky Stiff song from long, long, long ago. And then we'll do sound is going to be Gosu sample.new, also self, and it'll be communicator. Thank you. Live coding, ladies and gentlemen. All of these commits are available in my GitHub repo if you guys want to follow along with that. And just in case, I can always check that out if I totally screw something up. Just go to github.com/blowmage. What's that? How do you spell that? Blowmage. BLOWMAGE. All right. So, Blowmage. All right. So what I'm going to do is I'm going to say sample.play whenever ID is going to be X. So keyboard X. Right? So no, so the song is always going to play, and then the sample is going to play whenever I hit X. So we're good for... So sample sound. Oh. Oh, I see. Yeah, right. Okay, let's see if this even works. Cannot open file. Yeah, it is a wave, that's right. I did not convert that. Enjoy a little Why the Lucky Stiff. Okay, there you go. So that's how easy it is to use, right? You create an image object. You can either create that from text, or you can load an image on the file system. You can create a song object or a sample. You can play that. It's straightforward. It's not very difficult. Less than 25 lines of code, and we're good to go. So let's take a look at maybe a little bit different example. I think we have to go through some more slides. Okay, was that fun? Show of hands, who liked that? Yes. Okay. When we are working within games, it is very common for people to talk about sprites. Has anybody heard the term sprite before? But I don't mean CSS sprites. Who has heard of sprite before, and not a CSS sprite? Cool, about half you. So what is a sprite? Can somebody tell me what a sprite is? What's that? It's a bitmap? Typically, yeah. It's a region on the screen that you're gonna draw to, right? It's pretty common when folks are in their games that they'll create an object that's going to be responsible for printing to the screen, and they're going to call that a sprite. It's also really common for these concepts to have something known as a sprite sheet. A sprite sheet is a special case image that can be divided into columns and rows, and each cell of this larger image has a small incremental change in some animation that we're going to show. So in this case, we've got my little Ruby guy, and he's slowly moving his legs, his inverted feet, to walk. I didn't do the animation. It looks kind of funny to me, but it works. And this is a sprite sheet. Okay, so let's see if we can get this working. So we're going to create a new directory called sprite. All right. And we're going to create a brand new file. We're going to save that as sprite.rb. And we're going to do the same thing we did before. We're going to require Gosu. All right. We're going to create a new class called sprite game. It's going to inherit from Gosu window. Okay. And then at the end of it, we're going to call sprite game.new.show. And that will tell Gosu to play this game for us. We need an initializer with a width of 800, a height of 600, and full screen of false. And then call super to let Gosu know about this. Let's see if we can get this to work. Sprite. Okay, cool. So we got the window. We don't have anything happening in here yet, but we'll add to this. In fact, I can't even exit. Canceled out. Let's check out exercise 2.1. I'm confused by that. Unable to read current working directory, no file. Oh. Okay, git checkout ex 2.1. There we go. CD sprite. Here's all my files. We've got a sprite and this player image. Okay, so in my sprite game, again, the width and height are 800 by 600. I'm going to create a new sprite object passing in the window. On button down, If it's escape, we're going to close. When the window has update called, we're just going to pass that update down to the sprite object. And then when draw is called, we're going to also tell the sprite object to draw. So let's look what's in the sprite object who is responsible for printing to the screen. When it's created, we're going to have this window object. We're going to store that in @window for later. We're going to create a new image from player.png. And then we're just going to center that image by taking the window height, dividing it by 2, offsetting it by the image height divided by 2. And we're going to draw that. So Ruby sprite, there we go. Our little guy doesn't do anything, but again, hit escape, he closes. So let's make him do something. In update, because we're holding on to this window object, we can inspect the window object to ask it questions. One of the questions we can ask is whether or not a button is down, right? So what I might say is, like, I want my x value, my position, my x coordinate. I want to update it by -5, -5 if my button down is keyboard left. Okay. Let's see if that guy works. Okay. So when I press left, and if I hold left, he's just going to move. I don't need to press left every single time for every single loop, because every loop we're checking to see if it's depressed. So let's do the same thing for button right. Okay. Run it again. And now if I go left and right, we can move our guy, all right? Okay. Now, even though we're moving left and right, he's not changing direction. So the next thing I want to do is I want to take this little dude, and when he goes left, I want him to look left, okay? That's pretty easy to do, actually. When we call draw, we're giving it our x coordinate, our y coordinate, and this last one is the z index. That's the same for CSS on the web, so I'm assuming that most everyone here knows what the z index is. It's just how close to the camera something is. So if something's going to overlap, the asset with the higher z index is going to be on top. After x, y, and z, there's an x factor and a y factor. These default to 1, and these are just like how proportional the image is. So if we said, for example, that we wanted it to be 2 and 2, and we reran this, our guy is bigger, so he's been stretched. He's now 200% the size. One of the things we could do is we could say we want him to be -1, right? That's going to take that x index and then reverse it. So now, because he's -1, he's facing the other way. So I want to know if he's moving left or he's moving right. So I'm going to put like a direction value in here. And he's going to default to right. And I'm going to say, if we're pressing left, then I want my direction to equal left. And then otherwise, if we're pointing right, I want to move right, and I want my direction to equal right. Okay? And then when we draw, I'm just going to check for direction here. So I know that, thank you. So if direction is right, okay, then I'm going to draw as normal. Otherwise, we're going to be pointing left, and I want him to be facing the other way. Okay. Does that make sense? So what we've added is we've added this value, left or right. When we move left, we're going to set it to left. When we move right, we're going to set it to right. When we draw, we're going to take a look at that value and determine how we're going to draw. Okay? So I can move right. We're good to go. I'm going to push left, and he goes way far left, right? You see how he's flipping on that position, that first position? Right here. His origin is right there. So when we flip it, he's jumping. So we can fix this as well. When we draw the left, what we're going to do is we are going to subtract it by the image width. Okay? No. We're going to add the image width. Okay? So now he looks a little happier, right? So he can go left, he can go right, he can leave the screen. No one will ever see him again. Okay. That works, but it would work even better if he was actually animating. Okay? So what we're going to do is, instead of having this image here, which is a static image, we're going to have this idle object. And if we remember from the documentation on image, we have our normal constructor. Where did it go? Here you go. Initialized, but we also have these other class ones. We talked about from text, which will build an image from text. There's also this load tiles. This is where we're going to be able to look at and get our that sprite sheet. And it'll take that sprite sheet and cut it up into several images. So here, let's say load tiles. We're still going to ask it to do it from our window. But instead of player, we're going to go and we're going to grab a different file. Now, I don't have that here right now. So what I'm going to do is I'm going to quickly check that out. Let's see. Okay. Okay. So the only thing that we've added here, we've set, instead of having an @image object, we have this idle object. That's going to be populated by this load tiles, and we're going to grab it from this file, and that is the file, right? So it's a sprite sheet. The other thing we did is we have this new variable called frame, right? This is the frame that we want to choose from our sprite sheet. Every time we call update, we're going to increment that frame. And then when we call draw, what we're going to do is we're going to take the modulus of the frame and the idle size. So we're going to have 32 images. So if our frame is 174, we want to pull out whatever frame that is, which is like 18 or something. So we always want a number in our range of images for idle. And then we're just going to ask for that image out of our idle object, which is actually just an array. So that's the only change we've made. We've pulled our image out, and now we have an array, a list, a collection of images. We're keeping track of frame. We're incrementing frame on update, and we're using that frame to pull out the image from our collection so we can print it. Everything else is exactly the same. So if we run this, now he moves ever so slightly, right? But he still turns around. He doesn't jump anymore like he did before. Okay. So he's good. We're getting better. I would really like it. I think it makes sense for him to just be like, breathing and stuff while he's standing still. But if he's moving, I'd like him to look like he's moving. So let's add that. So let's check out EX 2.6. Okay. The difference here is now we have this second move object, the second collection of images. We've got one coming from this idle image and the other coming from this move image. If we look at the move image, you notice he's got a lot more movement. Everything else stays the same. We're still going to set a frame count. We're still going to increment it. Now we've also added this moving value here. And so every time we call update, we're going to reset moving to false. And if we have a left or right key down, then we're going to flip it back to true. And then when we draw, all we're going to do is, if we're moving, we're going to pull out the image from our move collection. Otherwise, we're going to pull it out from our idle collection. Right? So incremental change. So now as we move, at a glorious 60 frames a second, too. Look at that. Okay. So that's it. That's all it is. Now, this is running at as fast as we can do it. So 60 frames a second, we're pushing a new image up. There are other games that intentionally reduce the frame rate of the sprites down to like 6 or 8 frames a second because it's got that vintagey feel, right? But here's an example of something, these games are popular to have that vintage feel. They don't have to actually have that vintage feel because the capabilities are here to make a really compelling and interesting looking game. Am I over? Oh, geez. Okay, so wow, that was fast. All right, so one thing I want to show is next I was going to build this. There's a couple other examples, actually. Let me check this out real quick. So if we check out EX 3.5, we can do some parallax stuff. So parallax is an effect where you're going to move the background and the foreground at slightly different speeds to give the illusion of depth. All right, so we've got that. That code is all there. This is actually really easy. There's a method in Gosu called translate that will let you print your sprite to the background and then change the camera to follow it. So that's not very difficult at all. And then the last one is this game that I built that I was hoping to, here, the sound for this. I was hoping to kind of walk through how this is implemented. But a very simple thing, we're going to have a velocity, and then every frame we're going to try and pull that velocity down, pull that position down. And if you hit space, you'll jump back up on that velocity. And so we get this kind of positional game called Ruby Hop. And there should be sound, yeah. I don't know why there's not sound. Let's open that up to... Oh, okay. The sound's really important on this one. All right. Oh, this game is incredibly difficult. Oh. So I did that last night and this morning. Okay, lots of stuff. You can do parallax with it, which is kind of fun. Parallax. Woo. Yeah, so Ruby Hop, I just did that last night. It was super fun. The point I want to end on here is that if you're ever at a Ruby conference, or if you're ever at a Hack Fest, if you're ever at a user group, write a game, pair up with people, have fun, and thank you very much. My name is Mike Moore. And that's it.